Hello, this is the Mathematic Fanatic, and you are watching How Many Answers Does This Integral Have? So, I'm a calculus teaching assistant, and I noticed on the most recent quiz I graded that very few people got the question I'm about to show correct. This is for my Calc 2 class. I'm making this video for them to review, so I hope they're watching right now. And even when they did get it correct, there were so many different ways that it was solved. So I want to show you the different ways you can go about solving the following integral. Tan to the fifth of x dx. So method 1. You have tan to the fifth of x dx, which you can separate into tan cubed of x times tan squared of x dx, which by the sum of trigonometric squares identity, the tangent version of it, you can convert tan squared into secant squared minus 1. So that's where we get this part. So then you can separate that into two separate integrals, and then you can use u sub for the first integral of u equals tan of x, and du equals secant squared of x dx. That's based on the derivative of tan x, which we can then continue by repeating step 1 again for the second integral to get u to the fourth over 4 minus tan secant squared minus 1 dx. So then you can separate this, and this ends up being tan to the fourth of x over 4, and then you can do u sub again in either two ways. So for the first way, you can do u equals tan of x, or you can do u equals secant of x. Both work. So when you take u equals tan of x, you get secant squared x dx. If you take u equals secant x, you get secant x tan x dx. So therefore, both would cancel out nicely to get what we had originally, tan to the fourth of x over 4 minus the integral from u du. And then plus, we separated tan of x dx into sine of x over cosine of x all dx. So then using u sub with the variable v for the second integral, where v equals cosine x, we get the following. Tan to the fourth of x over 4 minus u squared over 2 plus the integral of negative 1 over v dv, which then we can just keep those two terms, but then this integral goes to minus ln of v. You can plug in v equals cosine of x to get this. Keeping the same two terms then is minus ln cosine of x. And the ln is absolute value, where we get tan to the fourth of x over 4 minus secant squared of x over 2 minus ln the absolute value of cosine x all plus c1, which is the same as tan to the fourth of x over 4 minus tan squared of x over 2 minus ln of the absolute value of cosine x plus c2. And that's why the plus c at the end is very important, because technically c1 equals c2 minus a half. However, there's actually another two ways to write this value, since the negative ln of u equals ln of 1 over u. So we get tan to the fourth of x over 4 minus secant squared of x over 2 minus ln of the absolute value of cosine x plus c1 is the same as those two terms are the same. The c1 is the same, but this is plus ln of secant x rather than minus ln of cosine x. We can do the same for the tan version of it with c2, and that's our solution. So, method 2. This method has some smaller variations just like the first method, but first we have the tan to the fifth of x equals secant squared of x minus 1 all squared, all times tangent of x. And that's because we just did the first two steps from the method 1 at once, which we can actually distribute out, and it gives us secant to the fourth of x tan of x dx minus 2 secant squared of x tan x dx plus tan x dx, which we know that from the first method that the integral of tan of x is ln of secant of x with the absolute values, and I'm using secant of x rather than the cosine of x because you'll see why in a second. So we can do u sub for the first and second integrals with u equals secant x. So du equals secant x tan x dx. So we get secant to the fourth x tan x dx minus 2 secant squared x tan x dx plus tan x dx. And that's all each integrals. So, which would give us the integral from of u cubed du minus 2u du plus we have ln of the absolute value of secant of x, which overall, that would give us u to the fourth over 4 minus u squared plus ln of secant of x, which, when you're plugging in u equals secant of x, we get secant to the fourth of x over 4 minus secant squared of x plus ln of the absolute value of secant x plus c3, which again, we know is just a constant off from the previous answer. Specifically, c3 equals c1 plus 1/4. Another way to find the same solution is by using u sub as soon as we get the secant squared x term. So in the following way, tan to the fifth of x dx equals secant squared of x minus 1 all squared times tan of x dx. But then we can do u sub right then and there, and we get u squared minus 1 all squared, all times 1 over u times du. So this comes from u equals secant of x, so du equals secant of x tan of x dx, which equals u tan x dx, because we already said secant x is u, which we can get 1 over u du equals tan x dx. And finally plugging in 1 over u du for tan x dx, we get what we found. So at that point, we have an integral where you can distribute out the u squared minus 1 all squared, and then take a 1 over u from it. That would give us u to the fourth minus 2u squared plus 1 all times 1 over u, which would give us u cubed minus 2u plus 1 over u all du, which gives us exactly what we had before, but with secant of x being the u for all the terms, which would end up giving us secant to the fourth x over 4 minus secant squared x plus ln of secant x. And there should be a absolute value right there. So in conclusion, technically this integral only has one linearly independent answer, but it really has an infinite number depending on the constant of integration, just like any indefinite integral. And while I cannot think of any reason off the top of my head to do so, it can even be expanded further by letting the part inside the ln of u be equal to ln of 2u or ln of 1000u, in which case it would be the exact same solution, but the constant of integration would be adjusted by ln of 2 and ln of 1000 respectively, since ln of a times b equals ln of a plus ln of b. So if you are ever stuck in computing an integral and think there is no way you will ever figure the solution out, just remember there isn't always just one way to solve a problem. Thank you.